Hello everyone, this is a VIZIO TV 50-inch. The customer, she said she didn't use this TV that much, and just one day she come to turn it on and the TV doesn't turn on. She doesn't know if it does happen after a power source or what exactly. The TV has no power. The TV model number is a V505-H19. It's already plugged to the power. Usually the VIZIO, when it's plugged to the power, we have a white standby here. But there is no standby light. If I press the power button, the light here doesn't come on. So let's take it apart and look at it inside. Okay, because we have no power, the first thing we go check is the power board to be sure that we have the standby voltage. So most of the power board, they have the connectors labeled with these numbers here. So this is a LED 1, LED 2. This is the LED backlight connector. This one here, we can see the 12 volt and the other stuff. Yeah, 12 volt. And PS on and backlight on. So we don't have a standby voltage here, but beside that we have a 12 volt. That 12 volt is going to go to the main board. This is the voltages that the main board. 5 voltage will go to the USB and the HDMI port. The 3.3 is going to go to the EEPROM, to the NAND and to the processor. 1.8 is going to go to the RAMs and 1.2 is going to go to the processor. Plus the main board is going to send back to the power board. It's going to send the 3.3 as a PS on or the backlight on. So that's the voltage that they come from the main board to the power board. So let's plug the power board. And we plug it to the power and let's see if we have that 12. So this probe is going to go to any metal piece, to any metal hole or under metal back cover. And we have 12 volt right here. It's nothing. We have another 12 volt right here. It's nothing. Of course, PS on is nothing. Another 12 volt. Right here, 12 volt, nothing. So we don't have the 12 volt on the outputs. And we check the capacitors because this is 2 transformers here, and one of them is for the 12 volt, one of them is for the backlight. And from the capacitors we can tell which transformer is for the backlight, which one is for the 12. Yeah, this capacitors is a 25 volt, and these capacitors here is 100 volt. So this 100 volts is for the backlight. This is for the 12 volt. Usually the company, if we have a 12 volt output, they put the capacitor like 16 to 25 volt. They can't put like less than 12 volt. See if we have the voltage in the big capacitors. In this area is a high voltage, we need to be a little bit careful. No voltage in the big capacitors. Why we have no voltage? We unplug the power cord and let's check for the short in the big capacitors. We have short. Alright, so now let's take the power board and see what's going on. Carefully we check the board, we don't touch the hot part. This is a cold section, this is a hot section. So there is a voltage here, and these capacitors, they can hold the charge. Alright, yeah, we did check before and we did see a short right here in these capacitors. But the short is not in the capacitor, it shows in the capacitor because it's easy to test over there. We can check the rectifier bridge. We want to see if that short showing here. No, This diode tested good. Of course, this fuse is gonna be open. Yep, this fuse is open. And let's check the output diodes. No short. No short. This is a diode. This one here is a diode. There's no MOSFET. These two pins is connected together. Yeah, there's a right here. You can see these two pins is connected together from the transformer. And that's the output pin. Alright, let's see, that's the backlight section, and let's see the MOSFET. That's a short over there. Usually the backlight MOSFET, it doesn't go bad first. Could be the 12 volt MOSFET is short and it show in that side of the backlight MOSFET. So let's check this one. We have short this side, we have short that side. All right. Yeah. This IC is controlling the 12 volt MOSFET, and this IC here is controlling the backlight voltage MOSFET. So let's go to the microscope to see the small component. Okay, that's the drain is going to the transformer. That's a jumper, and this is the transformer. That's the coil 1 for the 12 volt. This is the coil 2 for the VCC voltage. It's going to go back to the IC, to this IC. Must be this is the gauge, because that's a small trace, this is a big trace, and usually the source is going to connect to the negative side capacitor with the low ohm resistor. If we test from here to the negative side of the capacitor, it's right here, we are going to find a connection or low ohm, like 1 ohm or less. Yep, you can see a direct connection over there. The gate is connected to this resistor to here. We have, this is 10 kilo ohm. It's connected to the source to the gate. That's okay. And I see this side of this resistor is connected to this resistor. Let's be sure. Yep. It's give us 22 ohm. It's the reading in this diode. 22 ohm. Yeah, we need to check that diode and check it. Yeah, this diode is giving us a lower reading. No, this one is a 47 ohm basically. Yeah, not 470. That's a 47 ohm, and it's giving us a health. Yep. This diode and this resistor is connected on parallel. So the reading on this resistor is going to show in the diode. We need to take this diode, or we take just one side of it to measure it. And from here it's go to this 22 ohm. So here 22 ohm. Then from 22 ohm it's gonna go to this one, and that should be the gate of the switching IC. If we have this diode is good, there is a big chance the IC is still good, but we need to check that But first, let's remove the MOSFET. Is this MOSFET tested short? Go to the diode mode, short, and I'm curious if you still have the short. And here, no short, that's good. So this circuit here is still good, the MOSFET is still good. So let's check that diode, the small diode right here. Yeah, we still have a low reading, but many times that low reading is normal. 47 ohm, that's good. So the 47 ohm is the same reading as the resistor next to it. Okay, this resistor is look like it has some little overheat, but it's still good. This is a low ohm resistor. Yeah, that resistor over there, it has a little bit overheat. You can see this coloring right here, but the wire inside it's still good. It tested good. So next we're gonna need to take this diode and we measure it. If this diode is shorted and we put the MOSFET, that's gonna kill the MOSFET. So like we disconnect one side of the diode, just like that. And let's measure it. We are in the diode mode. Yeah, we are in the diode mode, and let's see 0.4. And if we flip, open. So the diode is good. Let's solder it back. Yep, that's good. The diode is soldered good. We want to see if we have the switching wave in the gate of this MOSFET before we put the MOSFET, and we be sure that the IC is good. Yeah, we're gonna need to jam the fuse. Let's do it. Okay, jump at the fuse. After we test everything, we put the MOSFET and everything work, I'm gonna put the new fuse. Okay, we plug the board to the power. We don't touch the hot side because there is a high voltage over there. And let's go and we check the oscilloscope. Now we don't have the wave. We don't get any wave right here. So must be the IC is bad as well. Okay, let's see. Do we have the voltage in the B capacitor? Yeah, we have 150 volt. One of these capacitors should be for the VCC. So that's the second coil. And we have a capacitor right here. Yeah, we have 17 volt, the voltage start, That's the voltage to start the IC. After the IC is going to cut the MOSFET, and we are going to have the voltage in this coil. That's going to be a VCC. But at the moment we do have the voltage start. But we don't have the IC is not switching. Here the voltage start is came to this pin. There is no voltage in the gauge. The IC is not giving any volt. Yeah, I did check here to see if I do have any similar to that IC. It's nothing, and so that's what we need, the IC and the MOSFET. But we can use this switching circuit board, or this one is a universal one. Okay, this one for a low amp devices, this one if we need a high amp devices. For this one, it's just a sample thing, we can use this one fine. So first we're going to need to check if we have the optocoupler that's connected to this circuit is connected to the ground. So we have 5 optocoupler over there. So one of them it should be connected to this IC, and the other side it should be connected to the ground. So let's put this one on the negative side of the capacitor. So we have all these, the 4 optocoupler is connected to the ground except this one. So maybe the second optocoupler, this one is for the feedback. That side it was the ground. This side, let's follow the trace. Let's go under this capacitor. Let's go to this 0 ohm resistor. Maybe it's go to here. Now let's go to this diode. Let's see. So let's go to this diode. No. Alright, let me check the data sheet for this chip and see where the feedback pin. So we have VCC, ground, driver, iSense, VNSense, protection control, and op timer. So usually the control is the feedback, the control of the input, and we can see it here in the schematic. It will be clear. That's the half of the optocoupler, and this is the other half. And we can see number 7. Number 7 is the control. It's going to the feedback, to the optocoupler, and the other side of the optocoupler is going to the ground. That's good. So that's what we need to know. And we are going to need to remove the IC. Alright, here we removed the IC, is good. So that's the pin number 1, 2, 3, 4, 5, 6, 7. Must be, that's the, yeah, must be, yeah. It's going to here, and we are going to see what optocoupler is connected to that one. So this optocoupler. Yeah, this optocoupler is connected to that one. Yeah, let's go to right here. And we have 10 ohm resistor. That 10 ohm resistor is gonna go yep, is connected to here, then to 10 ohm resistor, to this one, and to here, to the pin number 7. So that's the feedback. So the yellow, it will go to the drain of the MOSFET. The drain of the MOSFET is right there. That's the drain of the MOSFET. So let's start soldering the wires. So the yellow is the drain of the MOSFET. The black, it's gonna go to the hot side of the capacitor. It's gonna go to the ground in the hot side. Let's see if we have any close ground. In this resistor. Then the red is the VCC. The VCC should be the pin number 1 and the IC. Right here, the VCC. It's going to go to this capacitor. Let's be sure. From the pin number 1 right here to this capacitor. Yep, that's the VCC. Yeah, we install all the wires. The white wire is go to the positive side of the optocoupler. The other side of the optocoupler, we need to be sure is connected to the ground. The red is connected to the VCC to this capacitor. The black is connected to the negative side of the big capacitor, is on this resistor. The green will connect to the positive side of the capacitor. In this case, I connected to this resistor because it's closer. And the yellow is connected to the drain. Yeah, the first IC, I put it, and somehow one of the wires touched somewhere over there and it shorted. So this IC is burned now. can see 0.2, 0.7, 0.0 right here. It's good. So just be sure nothing to touch this one, plus be sure to discharge this big capacitor before testing or before start installing. We plug the power to here. It's unplugged from the source. I'm gonna plug it quick. I will disconnect it in case if I hear anything. I just unplug. Let's see, the IC is not hot. That's good. I'm gonna check the fuse. The fuse wire that we installed still there. Yeah, it's not hot. It's not hot at all. Okay, let's measure the voltage now. I'm not sure if this is a ground. .12 volt. I did see 12 volt. Here you are, 12 volt. It works. Alright, let's go install it in the TV and check. So it's connected here, fine. So safe from everywhere. Plus it's gonna be, that one is gonna be like a heatsink. Yep, we have the white light now. I can see the white light over there. I'm gonna press the power button. With the white light, it just flashes. Yeah, this white light is flashing non-stop. Check again. Oh, we have 4 volt here. We have 12 volt. But when we connect this one, is that 12 volt, it's go down. Let me try it again. So look, let's keep going up and down. So must be something here in the 12 volt line. There's no shortage to the ground, but why it's... Alright, let's replace the fuse. Same valley fuse is a 5 amp. Then check the fuse if it's good first. Yep, the fuse is good. Yeah. So I checked the main board. I don't see any short in it. If I check the power board, I don't know. This one look like a little bit swollen, maybe. So could be that's why the voltage is weak, because the capacitor is not good. Okay, let's take this capacitor. 400. Let's check this one. That's the capacitor over there, the last one. All these capacitors in the parallel mode except this one here. Yeah, that one is not with them. Let's discharge the capacitor and we measure it. Capacitor is still hot. 480. Yeah, the capacitor is still good, but it's a little bit looks swollen. So let's test this one. So after we replace the switching circuit with this one, it works. We have 12 volt, but that 12 volt is not strong. When we connect it to the main board and the main board try to turn on, that 12 volt it's dropped. That's why we did see the standby light flashing. So I did replace this capacitor right here. Yeah, we still have the same problem. And when I give 12 volt direct to this power, to this main board works fine. So let's go to the power supply at 12 volt. And we have, alright, let's try it. Let's connection this one to the ground. We're gonna watch if that 12 volt it's gonna go down. Let's see. Yeah, that's very low. Well, let's do 1 amp. And we plug it to the 12 volt. You can see it's taking 200 milliamp. And here we have the light is on. You can see it. Yeah. So it's mean the main board is on. And the main board is not taking a lot of amps, so likely is nothing wrong with the main board. And if we look carefully at this, you can see it has a lot of optocouplers here, but usually there is just one or two optocouplers. For the boards they give just 1 voltage for the TV to power on, like this one, it has just 12 volt. The power, the board, it will have just like a 2 optocoupler. One to check in for the voltage, and the other one to power on the other section of the power board. But this one, it has like 5 of them. And there is a big circuit here with this IC right there. So this optocoupler is communicating with that IC for other functions, and that's why that 12 volt is dropping. So next option is to replace the IC. And that's what we need to do. Alright, let's remove these ones. Yeah, the IC wasn't that expensive, about like $1 plus $5 shipping, of course. And we can replace the MOSFET. This is 6N H100C. So is a, or ADC. Is a 800 volt and 6 amp. We're going to replace the IC, then yeah, that's big capacitors. That's for that the pool board, and we have the IC right here. $1733. That's $1733, and this one $1733. So the pin number 1 is right there. Alright, now we go to the oscilloscope and see if at the gauge of the MOSFET, we're going to see if we have any wave. Yeah, at the moment we are not going to have the 12 volt output because the MOSFET is not on. But we are just want to see if we have if you have the wave in the gauge of the MOSFET. Alright, we connect the oscilloscope to the ground, and let's see if we have any wave over here. I did see one. You can see it's the wave, it's came and go. That's the wave start. Okay, so why that wave it came and go? Because we don't have the MOSFET. Yeah, the MOSFET is not, we didn't install the MOSFET yet. So the IC is just working with the voltage start. It came from the main power. There is, so from the capacitor we're going to have some dividing resistors like this one right here, because this is like a mega ohm. This is 1 mega ohm. So this one is going to take 160 volt and make it like 13 volt to the capacitor. To the VCC capacitor, and that's going to give us the voltage start. Now that's, if we follow the voltage start from this dividing capacitor, see this black trace, it's gonna go to this diode and it will go to the IC. That just to give us the first wave, the first switch. Then when we have the MOSFET installed, the first switch, it's going to make the MOSFET works. The MOSFET is going to send the wave to the transformer. The transformer is going to send the wave to this second coil. This one is for the VCC. And after that, this VCC coil is going to feed the IC. So the IC, it's no more getting the power from the voltage start. It's going to start getting the power from this coil to keep working. So the voltage start is just for the first wave. After that, the IC is going to get the VCC from the transformer. It's the same when you turn the car key. So the first, just to make the engine start. After that, the engine is keep going by itself. And the same way how with this one. Let's see if this MOSFET works first before we do anything. Yeah, is an N MOSFET, and that's what we need to know. So let's see the first test. Nothing explode, that's good. And we have 12 volt. That's great. Disconnect the main board and we see if the voltage is gonna drop. If it's working, it's good. If it doesn't work, then we need to get another power board. Yep, that's enough time on this one. Okay, so the main board is connected. Okay, yes, something good here. You can see the light is on. It's not going off, and sure we are going to have a stable 12 volt. Here you are, 12 volt stable. So it's fixed. Let's put it in the TV, then we see. So the standby light is on. And I did see the backlight. The TV is on now. Yeah, the TV is on. Yep, the TV working good. So that's all for this video. Thank you for watching. See you again.